My name is Paul B.J. Ransbury. I'm the President of Aviation Performance Solutions. This presentation is on technology and airline jet upset training. This particular discussion was developed around an article that APS published in Skies magazine. If you'd like to read that article and other articles by APS, please visit our website at apstraining.com/skies. In this presentation, we're going to discuss the loss of control and flight threat specific to air carriers. We're also going to address some technology advancements in two areas. Number one is the instructor operating station. The second one is in standardized pilot knowledge tools such as apps and applications. For the instructor operating station, we're going to show different ways that instructors can have a better understanding of what's going on through a full presentation from a variety of displays, and then individually look at displays that will reveal the validity of the training envelope that the simulator is in for particular maneuvers, a way to present the envelope and margins of safety, and then a method by which the instructor can easily see the control manipulations being accomplished by the pilots in the cockpit. This chart represents the fatal accidents and fatalities from 2005 through 2014 for the worldwide commercial jet fleet. We'll notice that on the far left side, loss of control in flight is by far the dominant causal factor, representing 40% of all fatalities in all categories combined. As we can see, a mitigation of this particular threat in some substantial way can have a tremendous impact on air safety. Let's get to the technology discussion and start with the instructor operating station. Very important for instructors to understand what is going on in the simulator in a few areas. Number one, as we can see in the top left side, is having a better understanding of how the simulator is actually performing in relation to the real airplane. Number two, what is the margins of safety? What envelopes are they approaching during the maneuver? What is the pilot doing on the flight controls? And what are the pilots seeing? These can be presented all together, or they can be broken out separately for analysis by the instructor. They can be viewed in real time, or they can be recorded, or they can be scrolled, whether it's during the brief in the simulator or the debriefing afterwards. Let's take a look at this particular diagram. This is an area that many instructors and training organizations are justifiably concerned about. This is the valid training envelope. And the way it's represented in this particular diagram, and this is just one way to do it, is a plot of angle of attack versus side slip, or beta. What we can see here are three different envelopes of validity, or what we could talk about is fidelity, of the simulator in certain areas. The dots represent where the airplane is operating, and these outlines, this particular one here that looks like a little airplane, are the boundaries as defined by the simulator manufacturer of the flight test data within which the performance of the simulator is in a high fidelity mode to represent the airplane. In other words, if all of the maneuvering for the particular situation accomplished in the flight test data area, the instructor would have high confidence that the simulator was flying the way the actual airplane would. The next one on the outside is wind tunnel data. In other words, this is areas where it was not safe for the test pilots to take the real airplane, but they could get valid data on the aircraft and its performance out to these particular limits. And these can vary based on how the wind tunnel was accomplished and how the manufacturer or simulator manufacturer has interpreted and plotted that data. In this particular case, we can see that some of the dots go outside the flight test data, which is not necessarily uncommon in an airplane upset, but we can see that it's relatively close to the flight test data, so the instructor would have pretty good confidence that the simulation that the particular simulator showed to the pilots in that particular maneuver was representative of the airplane. The airline itself would need to decide at what point would the data support the fidelity sufficient to impart effective training. Again, flight test data, wind tunnel data. Outside of this area, and this area up to these other dotted lines, are what are called extrapolated data areas, where it's done mathematically. This would be considered in some situations, depending on how the data was calculated, to be a low confidence area, or less fidelity certainly, than the flight test data. So for example, depending on how the airline decides to make decisions on effective training, in an airplane upset, they could maybe simply say that all data inside the wind tunnel is valid data. So if this particular maneuver showed plots outside of the wind tunnel data, then the instructor would have to redo the exercise because the low fidelity or the unacceptable fidelity of the simulator based on an airline's decision to dictate that was exceeded. And so the maneuver would have to be done again to ensure that negative training was not imparted to the pilots in the cockpit doing the airplane upset. The next one, this is called the VN or the VG diagram. What it represents is the G loading of the airplane. This is 0G, 1G, where most airplanes operate most of the time in a normal flight profile, 2, 3G. Limit load in most transport category airplanes is around 2.5G, with flaps selected down to 2Gs. And down here is the negative side of the curve. And we can see that in a clean configuration that a -1 particular situation here would be the limit load. But very often, when the pilot configures the airplane, for example, takes a flap selection, very often that particular limit load would go from -1 to 0. So what this is telling the instructor is that each data point, it's a combination of G loading and airspeed. And what this line represents right here, this arc, is essentially in most situations, at least in low Mach scenarios, is it represents the stall angle of attack, or CLmax, on the upper side of the wing, and this is on the negative angle of attack side of the wing. What this does is represents a margin of safety that the pilot has in any one situation away from the stall. For example, we can see that the distance from this particular plot to the CLmax position is pretty significant. So we could conclude that there's a large margin of safety, at least between the CLmax or angle of attack of the scenario and where the airplane is. However, as we start proceeding in here, we can see we're getting slower and lower G, and as we approach this, we can now see the red dots actually show that the airplane has exceeded the critical angle of attack, and the size of the dash marks in this particular technology presentation indicates how far the airplane has gone beyond that critical angle of attack, or CLmax. These dots are presented based on what is going on in the entire scenario, not just based on this one diagram. When the green dot is being plotted, it means that no other violations of flight envelope, G, or other factors that are being recorded, such as rudder pressure and other types of things, are not being succeeded. So technically speaking, the green dots would represent how the airplane is being flown in a valid, safe area of the envelope. As they start turning amber, it's a risk area, and red means that some parameter defined by the simulator manufacturer for that maneuver has been exceeded. And the plots will help cue the instructor as to what to think about and talk about in the debrief. So we can show here G loading, we talked about angle of attack and margin of safety, airspeed, and we understand now the color coding. In this particular area, it's often difficult for the instructor to see exactly what the pilots are doing on the flight controls. Certainly they can see gear selections or flap selections and throttle movements very often. Sometimes though in some airplanes it's hard to understand where the particular trim setting might be, or in an Airbus, for example, like this one, is what is the pilot doing with pressure on the control column? In other words, for the instructor to be able to see what is the pilot doing in this area. And there's also a presentation where, for example, the captain on the left side may have a black knob and the first officer may have a white one, and when there's disparity you would see both of them moving around with perhaps an average in the middle. That all depends on how the simulator manufacturer designs this. There's other things as well. In this particular chart here we can see this is the airplane's wing. This is the fuselage load in this particular situation. This is the tail load. This is now the wing load on each side. So for example, in this particular maneuver, it was clearly a rolling pull near the limit load of the airplane on the fuselage, but that upgoing wing, that rolling wing, exceeded the limit load. We can see here that it had turned red. It exceeded 2.5 G. So it's a cue to the instructor to understand different areas that are being exceeded. In here is a representation of rudder pressure, and if anything is exceeded based on what either the operator or the simulator manufacturer designs as a limit, it could be displayed on the IOS to debrief by the instructor. Also, system status indicators, autopilot, stall warning, stall protection, auto throttles as well are all indicated in this particular diagram. The point of this is to give the instructor a quick understanding of what's going on, what the condition is, and if there's anything being violated when it comes to limitations. The other area of technology advancement that we're talking about is going to be a way of imparting standardized knowledge to the pilots. This can include both the instructors and the line pilots. One example is the APS app on upset prevention and recovery training, where in this particular one takes a tool like the Airplane Upset Recovery Training Aid, breaks it down into about 8 modules that have individual tests per module. Then it has an interest model that includes things such as airline accidents or situations or animations in a way that is not unique to APS, but it's what the industry wants to have accomplished. And then down here in this area, the airline can customize it to the information they want to have. Maybe it's fleet information. It could be a particular type of airplane. Maybe it's an A330 process and procedures for upset training. And of course, the airline can brand this to their logo. Inside, it's very interactive. There's audio. There's also images that can be popped up. There's video, there's animation, there's tracking, and very easily going back to the main area by simply clicking on the module button or the home button, or whenever that a pilot is ready within any module, they can take the exam at any time. The interesting part is, though, if they take the exam and fail it, they can't take it again for 24 hours. It encourages people to understand and study the information as opposed to just quickly going through the test and doing it over many times to get through the process. This is great. This is very powerful. The nice thing about this particular app is it can be tied to the server. It can report the amount of time a pilot spends at any area, the scores they get in examinations, how many times they retake the exam, and also it can be integrated with performance and results from the simulator through a business intelligence system of some kind, or like some airlines, it can be completely disconnected where what the pilots do on this particular study area is their own business and the airline does not monitor it. It's completely selectable by the airplane. That presentation today was on the technology advancements in airline upset training. APS is the world leader in upset prevention and recovery training. In addition to online and technology solutions, we provide on-aircraft, advanced simulator, train the trainer, and integrated upset prevention and recovery training for pilots of all categories of aviation from all areas around the world. Thank you for your time today.